Here we have a combinations problem from section 12.9. It reads, from the 9 male and 10 female sales representatives for an insurance company, a team of 3 men and 2 women will be selected to attend a national conference on insurance fraud. In how many ways can the team of 5 be selected? Now, to ensure that we actually do get 3 men out of the 9 total, and 2 women out of the 10 female total, we need to set up 2 separate combinations. So actually what we'll be finding here to ensure that we get 3 men and 2 women will be the number of combinations of choosing 3 men out of that total of 9 men, and then we also want to find the number of combinations of choosing 2 women out of the 10 female sales representatives. And then we'll actually use from a previous section the counting principle. Remember that the counting principle, we used M times N, which was the number of outcomes from one event times the number of outcomes from a second, would give me the number of total outcomes for those to happen together. So the first event here would be the number of ways to choose men for our group, and then we'd have a number of different combinations of choosing the women for that same group. So let's find our combinations. Now up here, when I look at a combination, and we use combination instead of permutation because there is no order that matters here. We're just selecting them. They're all of equal standing. There's not a president, vice president, and secretary. It's just selecting 3 men out of 9. So a combination, when we have a total of 9 men and I'm choosing 3 of them, would be represented 9 and then our C 3. Remember that N is the total number I have to choose from, total number available, and 3 is how many I select at a time. We'll do the same thing with the combination or number of combinations of choosing 2 women out of 10 women. So the N would be 10 total. That's how many women we have available to choose from, and we'll select 2 at a time. And again, order does not matter. So from up above, we said that the number of combinations of choosing 3 men out of a total of 9 men would be represented with N, choose 3. This is a combination we already talked about because the order did not matter when I chose those 3 out of the 9. And then again from up above, the number of combinations of choosing the women, selecting 2 out of a total of 10. 10 would be our N, or total number of women. We're choosing R, which is 2. And then our formula for finding a combination is N factorial over N minus R factorial times R factorial. So for this combination, using the formula, I would have 9 factorial over 9 minus 3, which is 6 factorial, times R, which is 3 factorial. And this combination, using the formula, would be N factorial or 10 factorial over 10 minus 2, which is 8 factorial, times R, which is 2 factorial. So we can work that out a couple of different ways. I'm going to show you how to do it on the calculator as well as working it out by hand. So let's do a little work by hand first. Okay. So one way that I can simplify this, if I start to write out 9 factorial, that would be 9 times 8 times 7 times, and I'm going to stop at 6, and instead of writing 6 times 5 times 4 times 3 times 2 times 1, I'm going to leave that as 6 factorial since I know that I have a 6 factorial in the denominator. So I have that 6 factorial that will cancel out with the other one. I have also a 3 factorial, so 3 times 2 times 1 So when I go to cancel this out to simplify it, I can cancel out a 6 factorial from the numerator and denominator. And then if you also want to cancel out any other common factors, can cancel out a 2 and a 2 from the numerator with the 8, since 2 times 4 is 8. If we cancel out a 2, I'd be left with 4. And then I could also cancel out a 3 from the numerator and denominator, which would leave me with a 3 in the numerator. So I would have 3 times 4 times 7 left. 3 times 4 times 7 is 84. And now let's simplify the other combination, which would be 10 factorial. We'll rewrite as 10 times 9 times 8, and I'm going to stop at 8 and leave that as 8 factorial, since I know that I have the 8 factorial in the denominator. And then 2 factorial is 2 times 1. I'm just going to leave the 1 off. I can cancel out 8 factorial from the numerator and denominator. So I would have also a factor of 2 that could be canceled out, and I'm left with 5 in the numerator. So then 5 times 9 is equal to 45. So we would take 84, multiply it by 45, do that in my calculator. 84 times 45 is 3,780. Also in your calculator, we could come back up here and use the combination button under probability. So if I use combination of 9 choosing 3, then in my calculator, now under the probability key, option 2 is a combination. But I would first need to type in the total. So we said that the total, we had 9, it is a combination, and out of that 9, we're choosing 3. And then the other combination was out of 10, so a total of 10. For combination, go to the probability button, option 2. I'm going to choose 2. So there again, we've got the 84 times 45, which would give me the 3,780. We could have done that on one line. You would have wanted parentheses around both of your combinations, and you could multiply them together. But either way, you would have 3,780 different ways that I could choose a team from the 9 male and 10 female that would consist of 3 men and 2 women.